Hello and welcome to the Conversation Weekly.
This week, a simple question. Have predictions of global warming and its effects matched reality?
The shift in focus to what is actually happening now and already is really stark.
We speak to three experts to unpack the projections and see what's happening on the ground.
Given the dry conditions, these nomads end up grazing their cattle and it creates conflict.
I'm Dan Marino in San Francisco.
And I'm Gemma Ware in London. You're listening to the Conversation Weekly, the world explained by experts.
Tonight, a growing threat as the giant Dixie Fire carves a destructive path, now the largest single wildfire in California history.
This has been another year of scary and very big fires here in California.
Incinerating some 450,000 acres, an area triple the size of Chicago.
In Europe too, searing heat waves have sparked fires across Greece, Turkey and Italy.
In Greece, where massive wildfires have left hundreds of people homeless and forced thousands.
200 fires have been contained across southern Turkey in the past 8 days.
Wildfires are raging throughout the Mediterranean, from Algeria to Greece, leaving death and destruction in their midst.
But it's not just heat waves. In China, flash floods killed at least 25 people in July.
Flash flooding devastating parts of China, with several killed in a flooded subway system and dams and reservoirs swelling to warning levels as the region experiences some of the heaviest downpours in generations.
These events, at least to me, just scream climate change. With more CO2 in the atmosphere, the sun's rays enter the atmosphere and are trapped for the most part. This leads to just more energy in the system of Earth. And with more energy, extreme weather events become more frequent, happen with more ferocity, and things that might have been rare in the past are much more common.
Scientists on the UN's Intergovernmental Panel on Climate Change gave a stark warning in their latest assessment published last month.
The UN issues its alarming new climate report, calling it a, quote, code red for humanity. Scientists are warning the Earth is warming much faster than they thought.
We expect to see new extremes that are unprecedented in magnitude, frequency, timing, or in regions that have never encountered those types of extremes.
According to the IPCC, the Earth has warmed on average by around 1 degree Celsius above pre-industrial levels. We're likely to reach 1.5 degrees Celsius of warming by the 2040s. And it's unequivocal that human-induced greenhouse gas emissions are the cause of this warming. So this episode is broken into 3 parts. First, we talk about how scientists have improved their understanding of the connection between climate and extreme weather. Second, we look at one region of the world, East Africa, where reality and climate models don't match. And third, we explore new research that gives us the best picture yet of warming ocean temperatures and what they mean for rising sea levels. First, I called up Christopher White.
Dr. Chris White. I head the Centre for Water Sustainability and Public Health here at the University of Strathclyde in Glasgow. I study everything to do with extreme weather events, the impacts on us, on the built environment, how they're likely to change in the future, and what we need to do to build resilience against them.
We wanted to look at how predictions have changed. So, Chris, if you could take us back to some of the earlier IPCC reports, what were the researchers and the scientists and the climatologists, what were they kind of imagining in these early days of the conception of climate change?
The messaging, I suppose, of what the IPCC reports are doing has been broadly consistent over time. Even in reading the first assessment report in 1990, it made it very clear that we were to blame for the changing climate around us. And even then, it had statements that said human activities are responsible for increasing atmospheric concentrations of greenhouse gases. And there was a start even in 1990 to interpret that and say, well, what is that going to mean for us, our planet, the people that live in it?
What were the predictions made in the first IPCC report? Mid-90s, the first one, were they expecting 1 degree of warming by 2020, or how are we doing on our pace here? I mean, I don't want to say we've hit our goal because it's not a goal we want to hit, but are we on track here?
That's a very difficult question actually to unpack. And the reason being is that, of course, a lot has changed over 30 years or so of climate science. That includes the models, that includes the interpretation of the model output, and includes the scenarios that that are used within those models. So it's not a simple case of being able to draw a line that says, we said this here and this is what it is now. But broadly, yes, we're on, it's the wrong track, but we're on track for to what was perhaps what was predicted going through the previous IPCC reports. The key difference, though, is in the early IPCC reports, yes, there was a mention and a description of the potential impacts, what they were sure about, what they weren't so sure about. And extreme events were very much within there, but they weren't front and center. It was not the focal point. The focal point of the earlier IPCC reports was around greenhouse concentrations. It was around global climatology and underlying conditions. And as we've gone through and as we're starting to see more and more impacts from climate change, it's the extremes, the major events that we're starting to see more frequently and more severely. And it's those that have a much greater emphasis in the IPCC reports.
So if earlier IPCC reports were more focused on the processes of climate change, increased CO2, global warming being caused by humanity, you're saying now there's a lot more focus, especially the most recent report, on the impacts of this. We're talking extreme temperatures, extreme weather events, and just the fact that it's undeniably being caused by humans. Why is that? What's caused this shift in language?
The science has, of course, become more assured, as in there are a lot more people working in this space. There are a lot more questions that have been answered that perhaps even weren't envisaged back in 1990. And that's based on better understanding, I suppose, of our climate system, how things are connected to each other, and also the rise of other branches of science like climate attribution, which starts to try and put a fingerprint on any events that we see occurring and tries to make an assessment on how much of climate change and global warming is to blame for some of these events that we see. So you run a model after an event without that climate change influence, so without the extra CO2, and then run the models with our known CO2 concentrations and temperature rises, run the two together, and then you get an idea of what's the plausibility, what's the likelihood of this event occurring with or without climate change. It's actually climate attribution science that has led, therefore, to the statements that we have seen coming out of the IPCC. If you were to look at AR6, the most recent of the reports, there's some very hard-hitting, very stark assessments and warnings almost that come out of this report that were not possible back when that process started.
What were the recent IPCC reports talking about in terms of extreme weather events?
I think it's heat waves and the increasing temperatures and the knock-on effects from those very high temperatures that have come out incredibly clearly. Again, that shift in confidence of statements moving from caution to almost certainty. They're now saying that the warming climate has affected many of the climate extremes that we're seeing.
You just used the past tense there. Affected. Not even will affect, may affect, but affected as in it already has, correct?
Correct. Yes. Yeah, absolutely right. Even in the time of my career doing climate science and understanding extreme events, the shift in focus going from what's in the medium to long-term future to what is actually happening around us now and already is really stark. And I think that shift in, I suppose, the perception that it's a long way off and that we need to think about this, but maybe it doesn't matter if we don't think about it right now, I think is increasingly looking like we can't think like that. We have to think that these events are impacting us now. We only have to look at some of the events that have happened over the last few months, even this year, to see how climate is changing and it is influencing these extreme events. Again, temperature and perhaps the other things that temperature directly causes, wildfires, for example.
So can you give me a specific example here? What was something maybe 10 years ago we thought, 30 years ago we might have to worry about something like this, but it's actually happening today?
Let's take the extreme heat and fires that we've seen in North America in the last few months.
Western Canada and the Pacific Northwest of the United States have seen temperature records tumble as a dome of heat sits over the region.
So going back to sort of May, June time into July this year, a prolonged drought in that part of the world, coupled then with increasing temperatures, perhaps not so unexpected, as in that part of the world will often experience high temperatures. But then sort of roll forward into the summer months. There were parts of Canada, the town of Lytton in British Columbia, that experienced a temperature high.
Part of British Columbia reached 46.6 degrees Celsius yesterday, and that could be
just under 50 degrees Celsius. That was head and shoulders, several degrees warmer than anything that had ever been recorded in that area. It was then closely followed by wildfires that then pretty much destroyed the town. Could that have been conceived or even thought that was plausible, I think, 10 years ago? I suppose it's within the realms of plausibility, but did we think that realistically that would happen? No, probably not. And I think the reason for that is we're used to dealing with climate projections that talk about quite significant changes to our climate, but we're perhaps caging our statements around what could happen because of the uncertainty in the projections as saying they might happen in 30 years' time or 50 years or 80 years' time. To see these sorts of events happening right now means it's a major shift in thinking, both in terms of are we getting the climate science right, and are we therefore addressing it? Are we building resilience quick enough? Are we adapting to our changing climate quick enough?
Are there any other general trends? Is there anything else that's kind of ahead of the curve, if you will?
With some of the extreme weather events, it's much harder to get a clear trend from. Hurricanes and cyclones, typhoons, that's one of them. I think the correct term would be it's an area of open science, in that there's still a lot of people trying to make that assessment. And that's because of the complexity of those types of events. Heat waves are much easier because it's one variable, it's temperature and the build-up of temperature, and it happens over a large spatial area. Contrast that against extreme rainfall events and flooding, that they're typically a lot more localized than heat waves. So there's a lot more caution around the understanding of, I suppose, the trends behind extreme rainfall and flooding. But then we only have to look to the extreme floods, say, that happened in Western Europe this Northern Hemisphere summer.
Emergency workers in Germany and Belgium are still searching for hundreds of people missing after heavy flooding. More than 150 have now been confirmed dead. That figure is expected to increase.
Really, really severe floods that were predicted in terms of weather forecasting predictions. But they took a lot of people by surprise because of their severity. It's not so much that the IPCC reports are not saying that these aren't plausible, because they are. It's just that they don't happen that often, and when they do, they're very hard to forecast because they can, again, be so localized.
You've written in an article for us that, quote, some scientists are beginning to worry they might have underestimated how quickly the climate will change. And certainly this is due to some of that complexity, but can you explain why this was so hard to predict and how things are changing faster than potentially expected?
I don't think there's necessarily a question of have the climate models got it right or wrong. I think it's just we're still pushing the limits of what is plausible within climate modeling and the understanding of our climate system. And one of those points, and this is what I wrote about it in the article, is the fact that, of course, everything interconnects with everything else. Temperatures cause more moisture in the air, which then in turn causes more rain. And flash floods are a typical example of that. Flash floods often follow a very hot period of activity, often followed by thunderstorms, which then cause heavy downpours, which then cause floods. Or that connection between drought and heat waves that then set the scene for wildfires, like, again, we've seen in various places in the world, in particular this year. I think that area, that complexity and understanding the chaos and the dynamics within our climate system is very much an area where I think we're going to see a lot more development over the next 10, 15 years in the climate models that perhaps we haven't either understood or just haven't actually had the science capability to model these events that well in our climate models. We're very good at thinking about things in isolation. We have experts in floods, we have experts in drought, we have experts in wildfires and heat waves, and that's completely understandable because that's how we work in general in a lot of our society. But I think increasingly there's just that awareness that our system is very complex, our climate system. And so that there's this branch of science that has evolved probably in the last decade or so, which is compound events. Is the idea of linking events to each other and understanding if something happens, what's the likelihood then of something else happening? Or if two things were to occur at the same time, is the risk increased or decreasing? What the impacts might be. So the idea of cascading impacts and interconnections. That increasing awareness of what links some of these phenomena and the drivers behind them, I think in time will become a much stronger thread within climate science, and I think will help perhaps try and identify the reasons why some of these events are perhaps happening a little bit earlier than we may have otherwise thought they would in the climate predictions, and therefore might in turn hopefully improve those long-term predictions to see what's plausible, what is going to happen to our climate.
Chris, thank you so much for speaking with us. It's been an absolute pleasure, and I appreciate you taking the time.
Thank you, Dan. Thank you very much for having me on.
Our planet just seems so complex and interconnected, and everything impacts everything in some way that we still don't really understand, right?
Totally. And in addition to all the stuff Chris was talking about, he and many other scientists often talk about feedback loops when it comes to climate change. These are things like fires, droughts, rainfall even, leading to conditions that make those same events more likely or other events more extreme. It's just so hard to predict and honestly a little scary.
And we're not going to get into this today, but that's obviously why we've got to keep greenhouse gases down.
Now, Chris was also talking about how we have a much better understanding of extreme events such as heat waves and just temperature in general compared to what will happen with rainfall. Next, we're heading to a part of the world where predictions about rainfall have just been wrong. That's East Africa.
I'm Victor Ongoma. I'm a meteorologist by training, and currently I work as an assistant professor of climate change adaptation at Mohammed VI University Polytechnique in Morocco.
Victor now lives in North Africa, but he's originally from Kenya. Much of his research focuses on the climate and weather patterns of East Africa. And since we're talking weather, we need a baseline. So I asked him what rains are like in a normal year in East Africa.
We have two rainfall seasons. One running from March, April, May, what we locally call as long rains, and the other one in October, November, December, which we call the short rains. Of the two, the March, April, May season is more important because it supports most of agricultural activities. Looking at East Africa, most of the crops that are grown there are seasonal. For example, we have maize, which is the staple food there. So it's mainly grown during the March, April, May season. There's also something very important to note about the October, November, December rainfall. This season is mainly influenced by what we call global teleconnections. The features in distant places, for instance, El Nino and La Nina, which normally happens in the Pacific Ocean, it has a lot of influence on October, November, December rainfall over East Africa. And this is what normally causes dry and wet events over East Africa.
Okay, so if you usually have a long rain and a short rain, how have they been this year?
This year has been an interesting one. There was a March, April, May season, which actually I can say it failed because most of the parts of the region recorded below normal rainfall or depressed rainfall. And if that happens, what it means is that it affects agricultural productivity, mainly crop farming. Then, unfortunately, during June, July, August, although it's not a major rainfall season over the region, but there are some few places that record rainfall. Those places that record rainfall equally recorded near normal to below normal rainfall. So that means that we have had 2 consecutive seasons recording rainfall failure. To make matters worse, the climate outlook, that's the forecast for October, November, December, is already out, and it has shown that most of the parts of the region will equally record near normal to below normal rainfall. Following the failure of the 2 rainfall seasons, we are already witnessing dry conditions. Actually, it's a drought, and it's already causing a lot of negative impacts. In Kenya, for instance, the president declared drought a natural disaster on 8th of September.
And now President Uhuru Kenyatta has declared the drought a national disaster. The president subsequently directed the National Treasury and the Ministry of Interior and Coordination of National Government to spearhead government efforts to assist affected households, including water and relief food distribution.
Just imagine, this is very early, before even we get into the October, November, December season, which is also likely to be dry. So we are likely to experience drier conditions moving forward into the year.
What does that mean on the ground? How bad is it looking as far as, crop production, food accessibility, that sort of thing?
Actually, for Kenya, for instance, it may not look worse because we normally have food reserves. But in the long run, there's even likelihood to be more shortage. What's of interest at the moment is that we have had conflicts.
For decades, and particularly during the dry seasons, Laikipia region hits the headlines as pastoralists in search of pasture and water for their livestock invade the huge ranches which to them appear unoccupied land to feed their animals.
Actually, in some of the areas in central Kenya, between different communities for the last 2 weeks, the reason here is that we have the nomads or the pastoralists who move around with the herds of cattle looking for pasture. And given the dry conditions, the pasture are no more. And there are people who have vast pieces of land, which are conservancies. So what happens is that these nomads end up grazing their cattle in these conservancies, and it creates conflict between the landowners and these pastoralists. It's a big thing. There's deployment of the Kenya Defence Force trying to normalize the situation. All this is triggered by rainfall failure.
So droughts like this, certainly droughts always happen throughout history and are occurring. Are the droughts we're seeing now more frequent, more dry? How do they compare to historical trends?
In my view, droughts have become more frequent than before. I mentioned that the October, November, December rainfall is mainly influenced by systems that are distant away from East Africa. And the common one is the ENSO, which is El Nino-La Nina Southern Oscillation. So it influences the rainfall over East Africa in the sense that when there is an El Nino, the region records above normal rainfall. That's flooding. And whenever it's La Nina, the region records below normal rainfall, dry conditions. The El Nino-La Nina Southern Oscillation has a periodicity of around 2 to 7 years. So within 2 to 7 years, there's likelihood that we'll record a drought, then record a flood, drought, a flood, in that order. But what has happened in the recent past that there have been droughts almost every year, unfortunately.
Are rainfall levels roughly equal in total, but more extremes, dry, wet, or has there been an overall decrease in rainfall?
So records show that there is a decrease in rainfall in March, April, May, and there's a slight increase in October, November, December. On overall, there is a decrease because March, April, May is the main season.
Okay, so if droughts have become more frequent across East Africa, that's obviously not good, but is this what climate models had predicted would happen?
We have the models, most of which have simulated an increase in rainfall. This includes the latest report that was released by the Intergovernmental Panel on Climate Change last month, the IPCC Assessment Report 6. The same conditions were projected in the Assessment Report 5. So this is something that has been consistent in the models. They are showing that rainfall over this region is supposed to be increasing. It's increasing as per now, and is projected to increase throughout the 21st century. which is the opposite to what's happening.
So what is actually happening?
There are two different things here. When it comes to rainfall forecasting, for example, that one is normally organized by regional meteorological centers. And in that forecast, other than just saying that rainfall will be, for instance, the next season will be near normal to below normal, they also try to forecast the onset and cessation, which is very important because the farmers are interested in knowing when will this rainfall come so that they can plant at that particular time. For example, the forthcoming season, the October, November, December, most of the places, it's reported that rainfall is likely to be poorly distributed. So that means is that it is likely to make the situation worse. When it comes to models, it's something different altogether. And this is not even done in the region because these are global climate models run from various centers across the world. Most of these models simulate an increase in rainfall with increase in global temperature across East Africa, all through to the end of 21st century. From the assessment report 5, the projection period was starting from the year 2005. The current report, the projection starts from the year 2015. So that means that we are already into their projection period. But if you look at the records, for example, from the year 2000 up to now, you'll see there is a decrease in rainfall, even from 2015 up to date. But the model shows that from that year, 2015, moving forward, it's supposed to be increasing. That's where the paradox comes in. The models are giving an upward slope, but we are recording a downward slope. Then, hence the paradox.
And does anyone know why?
This is a complex issue. It's not something that has been there for long. I think the first time it came out, like it gained a lot of research interest, was around 2015, when the term paradox was coined. And since then, we have had a few researchers trying to explain why, but unfortunately, from my assessment, it shows that it's not yet clear.
So what you're saying is that East Africa is experiencing the opposite of what global climate change models have been predicting.
You are right. And although that applies mainly to rainfall, when it comes to temperature, I think the models tend to capture the temperatures well. And I think this is more or less a global picture that we are likely to record an increase in temperature almost everywhere. And that has also its own implications when it comes to East Africa because it has its own consequences. There are places that have been naturally cool, like the highland areas. Now they are getting warm. And it has an effect both on agriculture and the health. We have had cases of malaria outbreak and spread. Before, there used to be no malaria cases in this region. But because of the temperature increase, they are getting warmer. And now the mosquitoes can survive and easily multiply in these places. And we are seeing these cases, and the fear is that they are likely to increase moving forward.
One of the concepts we're trying to get at in this episode is how is reality differed from the models? And it seems like that is what you guys are experiencing in East Africa. What does that make you feel like as a meteorologist and a climate scientist? And, is that frustrating?
Yeah, this is an interesting question. And it's actually frustrating to the scientists who are trying to provide all these weather products. What it means is that it's very difficult to plan for long term. The reason being that the models cannot be trusted fully because they are showing the opposite of what's happening now. So we cannot trust what they are telling us will happen in the next 50 years to come.
So what are you expecting to see in the next couple years, and what do you imagine is a best case scenario, and what might be a worst case scenario?
Actually, there's a lot of uncertainty, so I cannot tell a lot based on the models that we have. I'm sure if you look at the latest report by IPCC, it shows that East Africa will be wetter, and we should anticipate more floods over that region. But that may be far away from reality based on what's happening now. So moving forward, I think the best case scenario is to adapt. And adaptation mainly in water conservation to boost agriculture, because the key thing here is agriculture. Secondly is to embrace climate smart agriculture, where we need to boost food productivity to enhance food security and at the same time minimize emission of greenhouse gases. So we are adapting to climate and also mitigating climate change. I think that's the best thing that countries, especially in East Africa and Africa at large, can go for.
Victor, is there any kind of closing words you'd like to leave us with?
I think my parting shot is that there is still hope. And this hope, it's anchored on planning, informed planning. So the people in these places, they should make use of the available resources. And the resources in this case are climate products provided by national meteorological centers. In as much as the projections for many years to come may not be very accurate, but the seasonal forecasts are relatively good. And thus can be used for planning for a short term to avert losses of lives and destruction of property.
Victor, thank you again. I really appreciate it, and best of luck with the coming seasonal rains. Hopefully you guys get a bit of rainfall.
Thank you.
It struck me as super surprising the fact that the projections and reality were just going in opposite directions. Often I feel like the projections might be a little off or there's be something slightly different, but they're all headed in the same direction. And it's really different to prepare for drought versus floods. So I can only imagine what these people there are going through.
Yeah, if your harvest and your livelihood depend on putting the crops in the ground at the right timing and knowing about the rainfall, you've got to be able to adapt and understand what's coming a month, 3 months, but also longer term.
Totally. And so it was fascinating to hear him talk about how they're relying more on local observations, hard data, and tweaking the models, at least in the short term, versus trusting these longer term predictions. So speaking of better data and improving predictions, we're going to next talk about some newly published research that really improved projections for ocean temperature and sea level rise.
My name is Kewei. I'm from Australia, Hobart. I work for CSIRO, and my research is on ocean and climate, specifically on sea level rise. My research tries to understand the past change in ocean and sea level and try to predict the further change in the future.
How long have we been looking at ocean temperatures, and what have we seen?
We have quite a good long history of measuring ocean temperature. One earliest activity of measuring ocean temperature I am aware of is back to 18th century on Captain James Cook's voyage. And for global scale observation of ocean temperature is to 19th century, about the 1870s, like the Challenger expedition. They took measurement of ocean temperatures while they travel across the globe. Despite these earlier measurements, it's only in the second half of 20th century there were enough observations we can estimate this ocean warming globally and consistently.
So what have people been finding in the general sense? Starting, you said, from the kind of mid-20th century.
We got quite enough observations, and right now we can say we are very confident that the ocean has been warming, at least in the past half century. And if we can compare the very early measurement from like the Challenger expedition and also our current modern observations, we can probably say this warming is likely to happen since the late 19th century.
We all know about climate change. More carbon dioxide in the atmosphere stores more heat, and there's just more energy in the Earth's system. So what fraction of kind of extra heat gets stored in the ocean versus in the air itself?
We have estimated that 90% of the actual heat from climate change is absorbed and stored in the ocean, but the number for the atmosphere is only 1%. The reason ocean is very important in storing this energy is because the ocean is huge. Think about the extensive volume, and also the seawater has much larger heat capacity compared to the air, and also the ocean circulation in the ocean can help to take the heat at the surface down to the interior ocean and store the heat there.
If 90% of the heat that has come from climate change is being stored in the ocean, what has that been doing to the ocean? Like, what? That's got to have a big effect, right?
Yes, it has a big effect. this warming ocean will directly contribute to sea level rise.
A newly published paper is warning that sea levels are rising more rapidly than previously thought, and the key
through thermal expansion, because when water warm up, it will expand. And also the ocean itself has a very large ecosystem, and a lot of animals live in the ocean. They can feel this warming ocean. So this warming has a major impact on marine ecosystems. And also will have the potential to fuel the extreme weather system. For example, the formation of tropical cyclones.
Parts of India and Bangladesh have been hit by the most powerful cyclone in 2 decades. Countless lives.
Which means this warming ocean will make the extreme weather system get stronger, and probably more frequent in the future.
So a lot of your work has focused on predicting sea level rise and how that might be connected to increasing temperatures. So can you talk about the study you recently did and were a part of and worked on? Like, what was it? What was the goal? And how did you guys start doing it?
The goal of this, our recent study, is to give an improved estimate of future warming and its contribution. And the major background is to predict our future climate. We rely on climate models that provided by modeling centers across the globe. And we got nearly 30 models, and we put them together. And the idea of this study is we got high quality observation from Argo project in the 15 years, and we got these model projections. Can we use this observation to check and also improve this projection from models?
What is the Argo project?
Oh, it's a very cool project. So Argo is an international program that collects ocean measurements using robotic flows. You have to think about we are sitting here, and right now there are almost 4,000 robotic flows working in the ocean and doing measurement for us. That's much more efficient than getting on the ship and do the measurement by ourselves.
That sounds like really cool, because you're not just getting a single data point at one location. You're getting like a whole cross section, like a continuous 2,000 meter cross section. What are you going to do with it now that you have it, and how did you improve future predictions?
So the first step is we got this observational record in the past 15 years from Argo project. And we also put model simulations of ocean warming over this period. And we can see this observational record is almost in the middle of the simulation, which means it's a good thing. But at the same time, we can see there's a very large spread in model simulating the ocean warming in the past 15 years, although they all simulated ocean warming. One interesting we found is greenhouse gas is actually the common and dominant forcing of ocean warming over the past 15 years and in the future by the end of this century. That means put those nearly 30 models together, we can get an estimate of the relationship between change in the past 15 years and change by the end of this century. So which means now we can provide projection with narrow uncertainty, and also these projections are kind of like confirmed by our current observations.
So you mentioned the relationship between the greenhouse gases and the ocean temperature and how they're more linked. Is that changing, or what is the trend there?
In the past 15 years, this ocean warming is driven by greenhouse gas for a given amount. And in the future, by the end of this century, this ocean warming is also driven by greenhouse gas by a larger amount.
So the influence of greenhouse gas on ocean warming will be higher at the end of the century?
Yes.
I got it. So if we're already seeing this and the ocean's going to warm faster, why? Is the ocean like getting its energy budget kind of full up, or what's happening here?
Essentially, our continued greenhouse gas emission and rising greenhouse gas concentration in the atmosphere, its effect is to kind of trap the heat and prevent the heat reflected back to the surface. So we got this energy imbalance, and then 90% of them going to the ocean, and the ocean will keep warming, and the sea level will rise through a thermal expansion. Our refined estimate indicate if we don't stop the emission and have the continued emission of greenhouse gas, the global ocean is likely to warm by 11 to 15 times the warming we saw in the past 15 years. That's a big number. that thermal expansion that could directly contribute to 17 to 26 centimeters of sea level rise.
Okay, so that's obviously bad. We don't want that. What does it look like if we keep warming to 2 degrees C above pre-industrial levels? What does that world look like?
We have also done estimate for that scenario. If we are able to quickly make action and reduce carbon emission and bring the surface warming within 2 degrees of pre-industrial temperature, that will reduce the number of ocean warming by almost half.
But even that is some significant sea level rise. So what does this mean for people that are living in coastal areas?
That means this rising sea level will change the landscape of the coast. This rising sea level will also bring more dramatic disaster to the coastal community.
Typhoons are not common in this part of the Philippines, but the people that live here are now being told that because of global warming, they should expect more typhoons like Bofa. And that
looking out of window, the ocean with warming, and there is a large amount of heat hidden beneath the ocean. That means this hidden heat potentially can fuel this extreme weather system like tropical cyclone, and this extreme weather system could possibly hit the coast. And at the same time, because the sea level is higher, it will increase the frequency of water level exceeding a particular flooding threshold, which means a larger chance of flooding for coastal community.
So we've got these improved projections. This Argo project is able to collect very good data. But how do we do better? Are there ways that we can make our models better, our predictions better? Can we be getting more data?
I think the key is still to improve the observations. For example, using the methodology from our study, we just directly further narrow down uncertainty from our estimates. And also, these Argo floats still not cover the deep ocean below 2,000 meter depths, and still not cover much of the polar oceans, which means our understanding of this area are still limited. With these improved observations, we are able to first understand the key processes in the ocean, and then check if this model can reproduce this important ocean process well, and how to improve that.
That's a very hopeful point to end on. So thank you so much for taking the time to speak with me today. It's been a pleasure, and hopefully we'll best of luck on further data, and please be in touch.
Thank you.
Kewei Liu there from CSIRO in Australia. You can find a link to a story he's written for the conversation about his new study in the show notes.
And keep following the conversation for more research and analysis about climate change in the coming weeks as we build up towards the UN Climate Change Summit taking place in Glasgow in early November. If you want to stay informed about some of the issues feeding into the Climate Summit, stay tuned because we're launching a new podcast series in early October in the lead up to the event.
To end this week's episode, we've got some recommended reading from Justin Bergman in Melbourne on the diplomatic falling out caused by the new defence deal between the UK, US, and Australia.
Hi, this is Justin Bergman, Deputy Politics Editor with The Conversation in Melbourne, Australia. The two stories I'm recommending for you this week are related to the new AUKUS security pact announced by Australia, the UK, and the US. The agreement sparked a diplomatic row with France after Australia scrapped a major submarine deal with a French company to pursue nuclear-powered submarines with the help of the US and the UK. My first recommendation focuses on the fallout from this deal for French-Australian relations specifically. This was written by two French authors based here in Australia, Roman Fati at Flinders University and Claire Riot at Monash University. They say the French have a long memory and a great sense of history, which means the French-Australian partnership is unlikely to be salvaged anytime soon. This could include losing France's support in negotiating a free trade agreement with the European Union. And my second story looks at the reaction to the AUKUS deal in Moscow, written by Alexei Muraviev, a Russian defense policy expert at Curtin University. He says nothing will stop Russia now from exporting its own nuclear-powered submarine technology, potentially fueling an arms race. The big question is, who is going to get it? That's it for me today. Hope you enjoy the reads.
Justin Bergman there in Melbourne. That's it for this week. Thanks to all the academics who've spoken to us for this episode, Christopher White, Victor Ongoma and Kewei Lu. And thanks to the conversation editors, Moina Spooner, Jack Marley and Stephen Kahn, and to Alice Mason for our social media promotion.
As always, you can find us on Twitter at TC_audio, Instagram at theconversation.com, or email us podcast@theconversation.com. You can also sign up for our free daily email by clicking on the link in the show notes.
If you're enjoying The Conversation Weekly, please follow the show and leave a rating or review wherever podcast apps allow you to.
Don't forget to tell your friends and family either.
The Conversation Weekly is co-produced by Mend Marawani and me, Gemma Ware, with sound design by Eloise Stevens. Our theme music is by Nita Searle, and all other music is from Epidemic Sound.
I'm Dan Marino. Thanks as always for listening, everyone.